Hi everyone, welcome to Integral Calculus. Today we explore lesson 6.1, area between two curves. Number 1, type 1 region. In type 1 region, we have the area between the two curves in terms of x, such as this picture right here. So how do we compute the area? We can sketch a stripe. This is a vertical stripe. The vertical stripe has a sample area. So to get the area of the entire region, we're gonna add the sample area. Add them up. Area would be summation equal 1 to n of the sample area. And because we want the exact area, we take the limit as n go to infinity. This is the limit of the Riemann sum. So we can express it as the integral from a to b of the sample area. So now look at the sample area here. You see that it is length and width. The length is the difference between the two functions. The width is the small change in x. And it will always be function above minus function below, or the upper function minus lower function. The width is a small change in x, dx. Yay! In this particular picture, it would be the integral from a to b. The length is fx minus gx, and the width is dx. Okay, let's take a look at some example. Example, find the area between y equal 2x squared plus 10 and y equal 4x plus 10. First thing to do is sketch out x, y. We can sketch the parabola like this. There's the number 10 right here. Y equal 2x squared plus 10. The straight line gonna go like this because it has a positive slope. So this y equal 4x plus 16, and this number is 16. The area between the two curves is this area. So in order to figure out the area, we need to do two things. The first thing is we're gonna find the area of a sample stripe. And the second thing is we're gonna figure out the two intersection point. Yeah. Sample stripe. It has the area, length and width. So the length is the upper function minus the smaller function. So length and width. Upper function 4x plus 16. Lower function 2x squared plus 10. The width is a small change in x dx. Simplify this, we have minus 2x squared plus 4x plus 6 dx. Okay. Next step is we want to figure out the intersection. So intersection. Set them equal 2x squared plus 10 equal 4x plus 16. So 2x squared minus 4x minus 6 equal to 0. Then we can factor this out to be 2 times x squared minus 2x minus 3 equal to 0. 2 times x minus 3 x plus 1 equal to 0. So the two intersection point is x equal -1 and x equal 3. From here, the area is the integral from -1 to 3. In here's the sample area, and that is -2x squared plus 4x plus 6 dx. Okay, find the antiderivative. We have -2/3 x to the 3 plus 2x squared plus 6x. Evaluate from -1 to 3. Do the substitution. We have a -18 plus 18 plus 18 minus, now sub the -1 in, 2/3 plus 2 minus 6. Work out the arithmetic and we have 64/3. Let's take a look at another example. Right below, in this one, we find the area of the region bounded by the graph fx equals psi x, gx equals cosine x, x equals 0, and x equals pi/2. Yeah. Sketch out. So this is the psi x right here. We know psi pi/2 is the 1 x equals psi x. The cosine x gonna be this. Cosine pi/2 is 0. Gx equal cosine x. X equal to 0 is the y-axis. And x equal pi/2 is this line right here. So as you can see, the region bounded by the curve is this one and this one. I'm gonna call it A1 and A2. Okay, so in A1, we can get a sample stripe. A1. Well, it has the area of something here, length and width. The length is the upper function minus the lower function. So cosine x minus sine x. The width is the small change in x, dx. Get a sample stripe in A2. It has the area of length and width. The length is, well, the upper function is sine x. Lower function is cosine x. The width is dx. And we need the intersection. The intersection of sine cosine, sine equal cosine when the angle is pi over 4. Yay! This means area is A1 plus A2. The area A1 is the integral from 0 to pi over 4, right, of the sample area. Cosine x minus sine x dx. A2 is the area from pi over 4 to pi over 2 of the sample area. Sine x minus cosine x dx. The antiderivative of cosine is sine. Antiderivative of sine negative cosine, so plus cosine x. Evaluate from 0 to pi over 4. Antiderivative of sine is negative cosine, and of cosine sine. Evaluate from pi over 4 to pi over 2. And carefully do the substitution. We have root 2 over 2 plus root 2 over 2 minus 0. Cosine of 0 is 1 plus cosine pi over 2 is 0. Sine pi over 2 is 1. And cosine pi over 4 is root 2 over 2. So we need root 2 over 2 minus root 2 over 2. Okay. Work it out, then we will have a root 2 minus 1 minus 1 plus root 2. So we have a 2 root 2 minus 2 as the area. Oh, pretty cool, huh? Okay, let's take a look at type 2 region. So in type 2 region, we would have the area between two functions in terms of y. And we will get something like the picture below. Yeah. So in this case, we will be using a horizontal sample stripe instead. Horizontal sample stripe. This one, it will have an area of length and width. The length here is the function on the right side minus the function on the left side. Right function minus left function. The width is Well, look at the sample stride. It is the small change in y. So dy. Yeah. And in this particular example, it would be gx minus fx dy. We have a sample area. And so similar to Taiwan region, the area between the two curves would be the limit of the Riemann sum. So that is the integral from, in this case, c to d of gx minus fx dx. Yay, let's take a look at some example. First example, find the area enclosed by y equal x minus 1 and y equal to y squared equal 2x plus 6. Let's try to draw them out first. Y squared equal 2x plus 6. The way we draw that is it looks like a parabola in terms of y. So we can solve for x there. See that y squared minus 6 is 2x. So divide both sides by 2. X is 1 over 2. Y squared minus 3. And so that is the parabola going this way. Minus 3. Yeah. X equal half of y squared minus 3. Okay. And the straight line is y equal x minus 1. So it's the number -1 right here. And that line go through this. It would look something like this. I'm gonna redraw it right here. Yeah. Just have to extend the parabola this way so we can see the bounded area. And this is y equal to x minus 1, or you can rewrite this as x equal y plus 1. So this is the bounded area, -1, right here. Well, the sample stride, it looked like that is a horizontal sample stride. So sample stripe. This sample stride has area of course length and width. The length here is the function on the right side, y plus 1 minus the function on the left side, half of y squared minus 3. The width, as you can see, a small change in y, dy. Simplify this, -half of y squared plus y plus 4 dy. Yeah. Well, we are integrate with respect to y, so we need to know the intersection. These two intersections right here, because we need to go from this point to this point. Intersection. Set them equal to each other. Half of y squared minus 3 equal y plus 1, right? Multiplied by 2, so you have a y squared minus 6 equal to 2y plus 2, and then we say that, yeah, move everything over. Y squared minus 2y minus 8 equal to 0, and we can factor this out. Y minus 4, y plus 2 equal to 0. So one of them is -2, and the other one is 4. Area would be integral from -2 to 4 of the sample area. -1/2 y squared plus y plus 4 dy. By the antiderivative, and we have -1/6 y to the 3 plus 1/2 y squared plus 4y. Evaluate from -2 to 4. Do the substitution, we have -1/6 times 64 plus 8 plus 16 minus, do the substitution with -2, -1/6 times -8 plus 2 minus 8. Work out the arithmetic, and we have 18. Pretty cool. One more example. It's the last one. The area, find the area between fy equal to 1 minus y squared and gy equal to y squared minus 1. Let's sketch them. X, y. So f of y is 1 minus y squared. So this 1, right, minus y squared is going to be a parabola going the other way. Here's the fy equal 1 minus y squared. Gy is y squared minus 1. Look at the area between them. These are two functions in terms of y. So we use horizontal stripe. Sample stripe has area, length and width. The length is function on the right side minus function on the left side. 1 minus y squared minus y squared minus 1. The width is the small change in y, dy. Simplify this, and we have minus 2y squared plus 2 dy. Oh, we got to get the intersection too. We need these two intersection point. Intersection. Set the two functions equal to each other. 1 minus y squared is y squared minus 1. So we have a 2y squared equal 2. So when y is plus or minus 1. Need 1, 1. And now it is clear to us that the area is the integral from -1 to 1 of the sample stripe area. minus 2y squared plus 2 dy. Notice that it's an even function because you can see the symmetry between the two areas from -1 to 0 and from 0 to 1. Or you can say that I'm going to call the difference between the two functions is say h of y equal to -2y squared plus 2 is even. So if it's even, then we can write the area as 2 times the integral from 0 to 1 minus 2y squared plus 2 dy. The reason why we use this fact because it makes the computation much faster. 2 antiderivative is -2/3 y to 3 plus 2y from 0 to 1. 2, right? Do the substitution for 1, get -2/3 plus 2. Substitution for 0, we get 0. And thus, this gives us 8/3. Thank you for watching. I hope you find the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.